Everything looks the same as before, solving trig equations, nothing's scaring me too much, so I'm gonna go ahead and just solve this. I know that this is a 3 sine, and if I really need to think about it as an x, I can think about it as an x and not worry about it too much. I see there's another sine over there, but those are just like terms and those can combine together. So I'm gonna go ahead and add plus 6 sine theta over here, plus 6 sine theta. Maybe I'm doing a little bit too much writing, but whatever. I got 9 sine theta minus 3 equals 8. Then I'm gonna go ahead and add my 3 to the other side, plus 3 plus 3. 9 sine theta is equal to 11. Then I'm gonna go ahead and divide by 9, 11 over 9. Now, that's not the answer, that's the end of the algebra. And now we need to look at our unit circle, and we have run into a problem. Okay. We've run into a problem where when is sine equal to 11 over 9? Did I write all this correctly? This is right?
Yes.
We add 6 the other side, we get 9, we add 3 the other side, we get 11, we divide by 9. Okay, looks pretty good. It says find to the nearest degree the solutions over the interval. Now, I'm already noticing that we're having a bit of a problem. Does anybody notice any problems that we're having? First of all, this is not a unit circle number. 11 over 9, it is nowhere on that unit circle, and that's why we have a calculator. When we're doing this stuff, we did a last worksheet where it had degrees and radians, and this question, is it degrees or radians? Degrees. So let's make sure that we hit mode and that we find ourselves in degree mode, because we need to be there. Now, because this is not a unit circle number, we're gonna need to do the inverse sine, the second sine, so that it will look like this, sine -1 parentheses 11 over 9. And that, when we type it in, should give us our answer. Second sine alpha y equals enter, 11 over 9 enter. Error. Getting a little bit of a problem here. Now, first of all, the reason I'm getting a little bit of a problem is 11 over 9, the fraction, is that above or below 1? It's above 1. 11 over 9 is, appreciate you, 11 over 9 is above 1. And so how many times does sine get up there above 1? 0, okay? It tries its best, but it gets to a peak at +1, and it never goes up to 11 out of 9. So a total possible answer is none. It just never happens. Maybe no solutions is another way we could write it. But it just doesn't work, okay? Now it didn't work not because we had to use the calculator, but it didn't work because the fraction just didn't look right. Okay, on the last piece of paper, I basically only gave you nice, neat fractions that always work. So let's see if we can figure this out and make it look a little bit nicer, okay? We've got 5 cosine theta plus 7 equals 10. Subtract 7, 5 cosine theta equals 3, divide by 5, cosine theta equals 3 over 5. That's the end of the algebra. Now it's time to use trig. Is that a unit circle quantity? No. Now, do we expect to get an error for this question?
No.
This one I do not expect to get an error, okay? Because that is not a number bigger than 1. It is totally guaranteed that cosine will have a value there. It is still in radian mode, or sorry, degree mode, said it backwards. So we're gonna do second cosine, 3 divided by 5. When I type that in, I got a theta. I got 53.13. How do we feel about that answer?
Yep.
Excellent. Now, it says find to the nearest degree the solutions. Now, if all we had to do was use the calculator, basically there's nothing to learn on this entire sheet of paper, right? Oops, it's not gonna be on the unit circle, type it in the calculator, get an answer. That's nothing new, that's not difficult, that's not new material. What is a little new is here is one of those solutions. What's the other solution? Well, we're gonna have to kind of think and use reference angles a little bit, okay? This is gonna be going back. What we figured out is that at 53, we have the angle that we want, okay? Now, where is cosine positive? 1, 2, 3, or 4?
4.
Cosine is positive in the 4th quadrant. And so what we need to find is which angle has the 53.13 whatever reference angle, the same angle we had in quadrant 1, except for it's in quadrant 3 now. Which angle would that be? Now, here's where we have reference angles. It's been a while since we talked those. You used to have them memorized, you used to have them written down on pieces of paper, but maybe you don't have them written down, maybe you don't have them memorized anymore. So here they are, okay? If you are in quadrant 1, you're good. It's just the angle, right? Super easy. Quadrant 1 is great. Your calculator is gonna give you a quadrant 1 answer most of the time. Everything looks pretty good. Quadrant 2, we like Roman numerals. In quadrant 2, it would be 180 minus A. You might remember this now, it might be coming back a little bit. So we would do 180 minus 53, but not for this question because we don't want quadrant 2. If we wanted quadrant 3, it would be A minus 180. So we would do 53, but that's not what we want. If we were in quadrant 4, we would do 360 minus A. So what do you get?
306.87.
That's right, I got 306.87 as my other angle. Let's move quickly and just keep the momentum going. Again, it's almost all the same, and we just need to find one extra angle. Now this question has distributing. Good news, distributing is only hard if you are a stupid freshman, and we are not stupid freshmen. So 2 tangent theta plus 8, 3 tangent theta minus 3. Move stuff around, maybe I subtract 2 tangents the other side. 3 minus 2 is only gonna be 1 tangent theta over here. I'm gonna add 3 and I'm gonna get 11. So I'm looking at tangent equals 11.
It's even worse.
Now, 11, is this less than 1? No. But remember how tangent looks. Tangent goes up, the tangent goes down. So actually, we are going to be able to find an answer for this. Let's go into our calculator and hit second tangent, 11. It's going to give us an angle. Theta is equal to 84.8. What quadrant is that in? It's in quadrant 1. Now, what quadrant do we want to look in? Where else is tangent positive? 3. So we want to go look. These are our old rules here. Let's do A minus 180. 84.8 minus 180. You're probably thinking to yourself, something's kind of being fishy here. Yeah, we're going to get a negative 95. Something's not quite right about that. What we're looking for is we're starting with this angle, and we're actually looking for matching angles, which is a little different from what these rules were for, okay? These rules were if you started with the big angle, how could you find the reference angle? Ours are just a little bit different, okay? If we tried it in quadrant 2, I think it would work great, 180 minus A. But in quadrant 3, what we're looking for is, here is 80, whatever it's supposed to be, 84. What we're looking for is this one down here. We're actually gonna do a plus 180 instead of a minus. So, 180 plus that number from before, and I got 264.8. That's our quadrant 3. Now, if you're thinking to yourself, oh my God, that's so crazy, I can't believe that he just switched it up on us. If you remember the old formulas and you try it and you realize, wait a second, I got a negative number, that's not very good. Well, it should probably jog something in your mind that says, oh yeah, I'm supposed to add it to make it work better. Okay, let's go to the back, and again, let's try to keep the pace up a little bit. I'm gonna try to speed up even more. The algebra stuff has gotta go. We gotta go fast. Okay. It says 5 sine theta plus 3 equals 2 sine theta plus 1. I'm gonna subtract the 2 over here to get 3 sine theta. I'm gonna subtract this 3 over there to get negative 2. I'm gonna divide by 3. Sine theta is equal to negative 2/3. This is still in degree mode, so I'm gonna stay in degree mode. It's negative 2/3. I'm gonna use my calculator. Second sine, negative 2 divided by 3. Now when I've typed that in, it tells me theta equals negative 41.81. You guys following with me on that? Okay. The reason that it tells you this, again, we've already learned this, but it has been a while. We talked about how the calculator is going to give you, for sine, either something in the first quadrant or something in the fourth quadrant. The issue is that we need a negative and sine is positive in the first, and so your calculator said, okay, I'll give you the fourth quadrant. Now the issue is, has this answer satisfied from being 0 to 360? No. So this answer, it is okay. Okay? It is in the right direction. It is not totally a wrong answer. But what we're looking for is still the 2 correct answers. How can we find these 2 answers? Just like we did before, we're going to think about those reference angles. We know that we're going to need one from quadrant 2 and one from quadrant 4. Instead of negative 41.81, where we've gone down 41, we're going to do 360 minus 41.81 to get 318.19. That's in the fourth quadrant, where we went down 41. In the second quadrant, we're going to be working again with that number 41.81, but this time we're going to use our rule of 180 minus 41.81. We're going to get 138.19. Now here's what happened, Chantries. When you typed it in, you probably did minus negative 41. Is that what you did? Now, that's not a crazy thing to do, because the formula says to use minus, and the number is a negative number. So I don't think that there's anything you did that was silly. Whenever we're doing these and we get these negative numbers and we want to use our formulas, we're just going to kind of pretend it's a positive number, right? Because that positive number is the number we want, except for it just can't tell you positive because positive is in quadrant 1, and quadrant 1 isn't allowed to work. So the calculator is trying to tell you a positive number without lying to you about question mark being good. Okay, let's see if this happens again to us. We've got 3 cosine theta minus 3 equals negative 4. Really short algebra, add 3. 3 cosine theta is equal to, add 3 is going to be negative 1, divide by 3. Cosine theta is equal to negative 1/3. Now, type this in the calculator, it's a negative number. That means the calculator doesn't want to tell you a first quadrant number. If I do second cosine, negative 1 divided by 3, enter, it tells me theta is equal to 109.47. Okay, what quadrant is 109 in? It's in the second quadrant. Is this a good enough answer between 0 and 360? Yes, so we're missing one more. Okay. What quadrant are we looking for? 3. Cosine is positive. All students take calculus, a smart trig class. It's positive in 1 and 4, so we want to not be those. We want to do 2 and 3. But it's a little bit tricky because our angle is bigger than 100, and so even our rules aren't going to work. If we try to do 180 plus 109.47, it's going to give us 289, which is too big. That's in the 4th quadrant. Anybody got any ideas where we can go from here? So what I'm going to start with is I'm going to do 180 minus this. The reason I'm going to do that is to try to figure out what is that reference angle, okay? We've got this angle here, which is 109, and I want to figure out what is this angle, because I don't really care about the 109. I want that small acute angle. So I did 180 minus 109.47, and I got 70.53. Now that's not the answer we want. That's too small. That would be a quadrant 1. What we want is the quadrant 3 version of 70.53. Does anybody have that number? We're gonna add it. It's a nice round, well, relatively round number. 250.53. We did our quadrant 3 rules, 180 plus the angle. And the angle has to be that acute angle there. Okay, let's do one more. The bell's ringing soon. Let's look at this. We've got 9 sine x plus 2 equals 3 sine x minus 1. We have to distribute 9 sine x plus 2 equals 3 sine x minus 3. We want to get everything on one side. 6 sine x plus 2 equals negative 3. We want to subtract 2. 6 sine x equals negative 5. We want to divide by 6. Sine x equals negative 5 over 6. Okay. We're going into our calculator. Second sine, negative 5 over 6. Because I did minus 3 from 9 to get 6. So I did all that. It tells me negative 56.44. That is an okay answer, but it's not really what we're looking for. We're looking for between 0 and 360. We're talking about sine being negative. That would be a smart trig. So this would be quadrant 3 and then quadrant 4 as well. Can anybody find the quadrant 3 or the quadrant 4 angles? We're going to want to be using this number, this 56. Just think of it as a positive 56. We do have 236.44 as an answer. That was 180 plus 56. That's the rule for quadrant 3. And the rule for quadrant 4 is 360 minus. When we do that, we should get 303.56. All right, we just fed run through two things of notes.